a lesson on molarity, otherwise known or also known as molar concentration. It refers to an aqueous solution. Remember, we abbreviate that with an AQ. And recall that a solute and a solvent mixed together make a solution. So the solute is dissolved, is what gets dissolved. An example would be salt, and the solvent does the dissolving, and an example would be water. So molarity, and the symbol is big M, is the bridge between volume and amount. So below you'll see the formula and the units. Molarity is the moles of solute divided by the liters of solution. And the units are big M equals moles per liter. So this will become our conversion factor. So to do the calculations, molarity, mole per 1 liter of solution, and its reciprocal, 1 liter per mole, are used as conversion factors in stoichiometric problems. So for a 3.0 big M solution of HCl, we'd say 3.0 molar solution of hydrochloric acid. Another way to write 3.10 molar HCl is 3.0 moles of HCl over a liter of the solution. So there are 3 types of problems for each. And so for each type of problem, you need to decide what you are looking for first, what's given, and what you need to solve for. So the first thing we're going to solve for or determine is the molarity. The goal is to solve for moles per liter. Those are the units. And you'll be given either moles in milliliters or grams in milliliters. So you have to convert the milliliters to liters using the conversion factor. 1 liter equals 1,000 milliliters. And written as a conversion factor or ratio, 1 liter over 1,000 milliliters also means 1,000 milliliters over 1 liter, and you have to determine which one is going to be appropriate to cancel and solve for the units. Grams to moles using molar mass, if we're doing that conversion, we're going to have, if you start with grams and you're going to have to convert to moles, and in order to do this successfully, you need to use the molar mass. And then you'll have to divide moles per liter in order to get the moles per liter. So let's practice that. So what is the molar concentration if 0.35 moles of NaCl are dissolved to make 45.75 milliliters of solution? Remember, the first thing we need to do is we need to convert the milliliters to liters. So we have 45.75 milliliters of solution, NaCl. We'll put that over 1. And then we're going to set up our fractions or our flow chart. So in order to get the milliliters to cancel, looking back at our options, we want the milliliters in the denominator to cancel the milliliters in the numerator. So we're going to choose this first stoichiometric or conversion factor. And so we know that 1 liter, in 1 liter of solution there are 1,000 milliliters of NaCl. And so, just as any good chemist would do, we have to make sure our units cancel, milliliters of NaCl and milliliters of NaCl. And then you want to find the product of the numerator divided by the product of the denominator. And the number of liters of NaCl solution is equal to 0.04575 liters of NaCl. You want to keep this number unrounded until the end. So now we have liters, and in the problem we were given moles, so now we can divide moles per liter to calculate big M, molarity, or molar concentration. So we will simply divide 0.35 moles of NaCl divided by 0.04575 liters of NaCl. And when we do the math, we end up with 7.7 sig figs moles per liter of NaCl, which is also equal to 7.7 big M molar concentration of NaCl. So that's how you determine the molarity of that solution. So here is determining molarity part B. What is the molar concentration if 63.2 grams of NaCl are dissolved to make 1.25 liters of solution? So in this case, we have to convert the grams to the moles. So we're given the grams, 63.2 grams of NaCl. We have to use the molar mass in order to convert to moles. So the molar mass for NaCl is 58.44 grams of NaCl in a mole of that solution. So the grams will cancel and we'll end up with a number just over 1.06605. Keep going with those numbers according to your calculator. Moles of NaCl. And then you want to keep all numbers until the end. We'll round one time at the end. So keep all numbers until the end. All right, so now we have moles and we have liters, so let's divide them. So the molarity for this particular solution equals 1.06605 moles over 1.25 liters. And we're going to go back to the original measurement, which has 3 significant digits, and we're going to round to 0.853 big M molar concentration of NaCl solution. So that's one type of problem for determining molarity. The second type of problem is to determine the mass. So if you're given the grams or the moles, if your goal is to solve for mass, you want to solve for the units, grams or moles, but you'll be given molarity and volume. So you're going to use big M as a conversion factor. And remember that big M equals moles per liter, so we use this as a conversion factor, just like we used the mole ratio and molar mass previously. So here's an example. How many grams of strontium chloride, SrCl2, are required to make 50 milliliters of 0.18 molar solution? Remember, molarity, moles per liter, and its reciprocal is our new conversion factor. All right, so let's go ahead and solve this. So this is our conversion factor, so we're given the volume, okay? And so the volume is 50, not just 50, 50.00 milliliters of SrCl2. I'm going to put that over the number 1. We've got to convert the milliliters to liters. So we'll use in 1,000 milliliters, there's 1 liter. And then we're going to use this conversion factor. So now we've canceled milliliters and we have liters. So to cancel liters and get to moles so we can convert it to grams, we need to use our new conversion factor, which is molarity. So we know that in 1 liter of any of this solution, there's 0.18 moles of the salt SrCl2, which is the solute. Then you'll multiply that by, so the liters cancel and we have moles, but we need grams. So we need to multiply that or continue our flow chart so that in 1 mole of SrCl2, we have to figure out the molar mass, which is 158.52 grams of SrCl2. All right, so when we calculate or use, don't forget, you can use the control divide function on your calculator. You're going to get the product of the numerator divided by the product of the denominator, and it's going to be reported with 4 significant digits because that's how many were in the original measured value. So the reported value with the rounded value will be 1.400 grams of SrCl2. All right. And the third type of problem is determining the volume of the solution. So given molarity in grams or moles, And you'll notice in these problems, the reciprocal of molarity is going to be used where the liter is the numerator and moles is in the denominator. But we're still going to use molarity as our conversion factor, but in this case, it will be the reciprocal. So how many milliliters of solution are needed to make 0.755 molar concentration of SrCl2 solution, starting with 32.9 grams of SrCl2? Well, we're going to start with 32.9 grams of SrCl2 over the number 1, and that's because, remember, molarity is one of our conversion factors, and this big M really means moles per liter of solution. All right, so because we have grams of SrCl2, we need to use the molar mass, which we said was 158.52 grams of SrCl2 salt per 1 mole of SrCl2, so that the grams cancel. So now we have moles, and ultimately we want to get to how many milliliters. So we need to get to liters in order to convert the liters to milliliters, so that's how we're going to use molarity as our bridge or our conversion factor. So we know that in 1 mole of, in 1 liter of this solution, there are 0.755 moles, 0.755 moles of SrCl2 in 1 liter of SrCl2 solution, so that the moles cancel and the moles cancel. So now we've solved for how much, but how much in liters? We need to use our metric conversion in order to solve for milliliters. So remember that in 1 liter of any solution, there's 1,000 milliliters, so that the liters cancel, and we'll be solving for milliliters of SrCl2 solution. So when we find the product of the numerator and divide it by the product of the denominator, and in this case, we've used the molar mass as our conversion factor. We've used molarity as our conversion factor, and we've also used a metric conversion as our conversion factor. We can go ahead and find the product of the numerator divided by the product of the denominator, which is going to be reported with 3 significant figures or digits, and equal to 275 milliliters of SrCl2 solution, and you'll go ahead and box that answer.